This is Math 99 practice test for the final. This is problem number 16. And on this problem, we're given some data that's from a situation, and it says a ball was tossed in the air, and its height, h in meters, is given at 3 instances at different time, t's time in seconds. And notice we have at 1 second it's this high, at 3 seconds it's this high, at 5 seconds it's that high. So what we're supposed to do is take this data here and get a general formula that would fit this data. So basically we want to find A, B, and C such that if we plug in T, we get H. Yeah, and that would give us all the other points that relate time to height in this situation as well. So we have 3 instances, T and H. That would give us 3 different equations and 3 variables. So it's just basically a system to solve. So let me start to write what my system would be. So my first instance here, where T is 1, H is 49.1. I'm just putting that into the H spot. And that's going to equal when T is 1. So that would be A times 1 squared plus B times 1 plus C. And I can translate that into an equation. And I'm just going to switch the order just so it looks more familiar. So 1 squared is 1. So I have A plus B plus C, right? 1A, 1B, 1C equals 49.1. So that is my first equation for my first instance. My second instance is when T is 3. When T is 3, H is 47.9. So I have 47.9 equals A times, well, T is 3. So that would be 3 squared plus B times 3 plus C. So let me think about what that turns into. That would be 3 squared is 9, 9A plus 3B plus C equals that 47.9. And then my last example would be when T is 5. So when T is 5, H is 7.5. So let me plug that in. 7.5, that's my H value, equals A times T. T is 5 right now. So 5 squared plus B times T, which is 5, plus C. Translate, and then in equation that would be 5 squared is 25. 25A plus 5B plus C equals 7.5. Great. So now I have this system of equations. So I need to solve it to figure out what A, B, and C are. So I am going to erase this, make myself a little bit of space here for work. And what I'm going to do is turn this system of equations into a matrix. So in the first equation, I have 1A, 1B, 1C. The solution is 49.1. In the second one, I have 9 A's, 3 B's, 1 C. Solution is 47.9. And then the last one, I have 25 A's, 5 B's, 1 C. Solution is 7.5. And that 47.9 is a little messy. I'm going to try and clean it up. 47.9. 7.5. So now I have this matrix, and if I solve it, then what I'll have are these A, B, and C values. I can plug them back into this equation, and then I'll have my equation that fits that data. So I'm going to erase a little bit more, make myself a little bit of space so I can work a bit. Boop, boop, boop. Good stuff. So taking a look at this first case, I notice that I have a 1 and a negative 9. So if I make this into a negative 9, I could cancel them out. So I'm going to go negative 9 times equation 1 plus equation 2 is going to go into equation 2. So let me do a little bit of scratch work. Negative 9 times E1, that would be, I'm multiplying this by negative 9. Negative 9, negative 9, negative 9. And I'm going to have to go 49.1 times negative 9. I'm just doing it on my calculator. And I get negative 441.9. So, let me do this and see where I end up matrix-wise. My first equation, I'm just going to leave it 49.1. My second equation will be the second line plus negative 9 times the first line. So 9 plus negative 9 is 0, which is what I wanted to happen. 3 plus negative 9 is negative 6. Boom. 1 plus negative 9 is negative 8. And then I have 49.1 plus negative 441.9. I'm just doing it on my calculator. Oh, no, not 49.1, sorry. 47.9 plus that. Negative 441.9 plus 47.9. And I get negative 394. So far so good. The next thing that I want to do then is deal with that. So I want that spot to be a 0. So I'm going to use equation 1. And if I go negative 25 times equation 1, add that to equation 3, and put it into the equation 3 spot, I should have a 0 there. So I'm going to erase a little bit, do a little bit of scratch work. So negative 25 times equation 1. So those first ones are easy. That just makes them all negative 25. And then I have 49.1 times negative 25. And I get negative 1,227.5. Great. So now I'm going to add these two together. See what I get. So 25 plus negative 25 is 0. Negative 25 plus 5 is negative 20. Negative 25 plus 1 is negative 24. And then negative 1,227.5 plus 7.5 is negative 1220. Good. Okay. So let me rewrite what I have so far with this. My first line is all ones and a 49.1. My second equation, I notice they're all divisible by 2. So I'm going to do that just to give me some smaller numbers. Divide them all by 2, negative 3, negative 4. 394 divided by 2 is negative 197. And then this next one, it's still going to be a 0. I notice that these are all divisible by 4. So I'm going to do that, divide all these by 4. So that makes this a negative 5. That makes this a negative 6. And 1220 divided by 4 is a negative 305. I could have divided it by negative 4 and just made them all positive, but we'll see what happens. All right, so now I have this system. So now what I want to do is make it so that I have, maybe a 0 here. And so since I have a negative 3 and a 5, I'll make one of these 15 and the other one a negative 15, and then I'll add them together and something will go away. So that will be, how about I pick my color and say negative 5 times equation 2 plus 3 times equation 3. We'll go into the equation 3 spot. Let's see what happens if we do that. I'm going to do some scratch work down here. So negative 5 times equation 2. So that's this equation. So negative 5 times 3 is positive 15. Negative 5 times negative 4 is positive 20. Negative 5 times negative 197 is 985. And now 3 times equation 3 would be negative 15, negative 18. And then 3 times 305, negative 915. So if I add those together, 15 plus 15 is 0. Oh, I already have a 0 here. 15 plus 15 is 0. 20 plus negative 18 is 2. 985 minus 915 is 70. So now my system is this. All right, so now with that system, I can do some work to back solve, because now I have it in terms of a system. So now I can translate it out of a matrix back into a system of equations. So this would be the same as 1a plus 1b plus 1c equals 49.1. That's a 1. My next equation would be 0a minus 3b minus 4c equals minus 197, negative. And then my last equation would be 0a, 0b, 2c equals 70. And then from there, it's pretty easy. It looks like c must be 35. And so if c is 35, I can plug it into this equation to get b. So negative 3b minus 4 times 35 equals negative 197. 4 times 35 is 140. So negative 3b minus 140 equals, this is still a negative, 197. Ugh. Add 140 to both sides. Negative 3b equals negative 57. Divide both sides by negative 3, and b equals 19. So far I know that c is 35, b is 19, and now I can use both of those pieces of information to get a. So I'm going to erase a little bit more, give myself a little bit of space, since I have a very limited workspace. So that means that a plus, let's see, b is 19, plus c is 35, equals 49.1. So 19 plus 35 is 54. A plus 54 is 49.1. Subtract 54 from both sides, and it looks like a is negative 4.9. Great. So that means then that I know my A, B, and C, and it feels like I'm done, but I only have one more final thing to do, and that's to write the actual solution, which is the generalization of this. I know that H equals A. Well, I know A, it's negative 4.9 times T squared, plus B, I know B, 19 times T, plus C. And it's easy for me to check. If I plug in 1, I'll get 49.1 out. If I plug in 3, I'll get 47.9, etc. So there's our answer right there.